Now I would like to show you a few example problems before the demonstration. First off, when a discus is thrown, the horizontal axis is not affected by gravity, while the vertical axis is always affected by gravity. Remember in the previous video when I showed you guys how x equals velocity times cosine theta and y equals velocity sine theta? Well, we're going to use these to show how far the discus has been thrown. Now we need to add more information to complete the equations. So we have x equals velocity cosine theta. Now we have to add time. So the new equation will be x equaling time times velocity times cosine theta. Now, since gravity is affected, it has an effect on the vertical axis, we need to add that to the equation. And also we need to add time, just like in the horizontal equation. So we have y equal to velocity sine theta. Now we need to add time and gravity. In gravity, it's just half gravity times time squared. So our new equation will be y equal to time times velocity sine minus half gravity times squared. Now, this is the application problem. For every problem, there is given information. So for this one, the velocity of the discus will equal 87 feet per second, while the angle of which you released it is 68 degrees, and the time is 5 seconds in the air. So we take our two equations that we got prior, and then we simply just plug and chug. So 5 seconds in the air will go in for time, 68 degrees will go in for theta, and 87 for velocity. Same goes for y. We take 5 seconds for time, 87 for velocity, and then 68 degrees. The only thing different for the vertical equation is taking 32 divided, remember 32 is gravity, and divide that by 2, so you get 16. Then we take the time and square it, so 5 squared. Now, all we have to do is add it to our calculator. So we get 5 times 87 cosine 68. We get 162.95. Then we take 5 times 87 sine 68 degrees minus 16 times 5 squared, and we get 3.33. After we calculate, we're pretty much done. Our final results are x equaling 163 feet and y equaling 3. So after 5 seconds, the discus has traveled about 163 feet and is roughly 3 feet above the ground. So these equations help you find how far you have thrown the discus in certain conditions, as they also help you find how far you have thrown the discus after so many seconds.